So probability is what is the likelihood that an event is going to happen? Well, it was easy when we were doing one event. What's the probability of drawing one green marble? What's the probability of drawing a face card? What's the probability of rolling a dice and getting a 6? But what happens when we have two things that are happening and we want to know what's the probability of this same situation happening? What's the probability that I'm going to reach in my sock drawer and get two socks that match? So we have independent events. Independent events means that they are independent of each other. They do not impact each other. What you want to look for, the key words you want to look for in the problems is you put it back. I grab one sock, or, well, socks you wouldn't put back, but I grab a marble, I put it back, and then I grab another marble. What's the probability of drawing a green and then a yellow? But you put it back, okay? And what you would do is you would find the probability of each one of them and you would multiply it. Dependent events means that they depend on each other. What happens second depends on what happened first. Okay, you always assume that you get what you want. You'll see what I'm talking about when we do some examples. You're going to look for words like, what's the probability of this and that happening? You're going to keep it. You're not going to replace it. So imagine you're going to reach in the bag. You're going to draw a green marble. We want to know what's the probability. So we reach in, we draw a green marble. Hey, look, that's what I wanted. We set it to the side. Now we reach into the bag again. What's the probability of doing it again? Okay, so that is, you're still going to multiply them, but it's the probability of A and then the probability of the second event happening, assuming that the first event did happen. And then we have what's called mutually exclusive events. It doesn't matter which one happens. Either one of them makes you happy. It's a keyword of or. And really, this could go back to just plain basic probability. What makes us happy over what can happen. And we can go back to that. Or you can find the probability of those two events and add them together. So when you have and, I want this and that to happen, you multiply. When it's or, I want this or that to happen, you would add them. So let's look at some examples that go with this. So suppose a bag contains 5 green marbles, 3 blue, 6 yellow, and 4 white. So we have 18 marbles in all. Okay, that's our can happen, right? That's what we want to happen. Or that's our can happen. Now let's see what we want to happen. I want to know first, let's review what we did yesterday, drawing a blue marble. Just a blue marble. That's all I want to do is draw a blue marble. Well, the probability that I'm going to draw a blue, there are 3 blue and there are 18 marbles in the bag. We reduce that and we would get 1 out of 6 or 16.7%. You can continue to change those, right? 16.7% if we change those to percentages. All right, so now let's look at some compound probabilities. So drawing 2 green marbles, if the first marble is replaced, okay? So we reach in the bag, we want to know what's the probability of doing a green and then a green. So we take each event separately. First, what's the probability of drawing a green? Well, the probability of drawing a green, there are 5 green marbles and there are 18 marbles in the bag. I reach in the bag. Oh, look, I got a green. I put it back in because I replaced it. I put it back in. Now I want to know what's the probability of drawing a green again. Well, I have 5 green marbles in the bag again, and I have 18 marbles in the bag. And I want what's the probability of both of those things happening, then I multiply them together. So 5 over 18 times 5 over 18, you get 0.0772 or 7.7%. Okay, now let's look. What happens if you keep the first marble? Same thing, probability of drawing 2 greens, a green and then a green, but you're going to keep the first marble. You could also draw them at the same time. This is how you would do it if you were reaching in and drawing at the same time. So probability of drawing a green. There are 5 green in the bag and there are 18 marbles in the bag. I reach in, I draw. Oh, look, I got what I wanted. I got a green. I set it to the side. Now I want to know what's the probability of drawing another green. Well, now there are only 4 green in the bag and there are only 17 marbles in the bag because I set one to the side. And I multiply those two events together. So 5 divided by 18 times 4 divided by 17, you get 0.065 or 6.5%. So it's not very likely that you're going to draw a green and a green when there are only 5 green marbles in the bag. Okay, so now let's look. What about drawing a blue and then a yellow if you keep the first marble? So what's the probability of drawing a blue? First, there are 3 blue marbles and there are 18 marbles in the bag. I reach in, I draw, I get a blue, I keep it. And now, how many yellow are there? Well, there are still 6 yellow in the bag because I got a blue the first time, but now there are only 17 marbles in the bag. Well, before I reached in to get the next one, there were only 17. And I multiply those two together. So 3 divided by 18 times 6 divided by 17 is 5.9%. Okay, what's the probability of drawing a green or a yellow? Now this is this is that or. Before it was this and that. Now this is or. There are 2 ways you can think of this. I can say, okay, what's the probability of drawing a green? Well, the probability of drawing a green was 5 out of 18, and the probability of drawing a yellow was 6 out of 18. With an or, you add. So you would add those together. Well, 5 over 18 plus 6 over 18 is 11 over 18. Now, I could have just skipped straight to this. How many make me happy? Green and yellow make me happy. Well, 5 green and 6 yellow is 11 marbles make me happy out of the 18 that are there. So you don't even really have to think about adding them. You can just do that part kind of in your head. You don't have to actually physically write that down to do that part. Okay, what about drawing neither a blue or a yellow? Well, if I don't want to draw a blue or a yellow, then I want to draw a green or a white. Well, there are 9 marbles that make me happy out of the 18 marbles in the bag. Okay, and so that's how you just, with that or, right, the or and the nor, they go together. But you would add the blue and the yellow together, and I don't want those, I want the other ones. Okay, and so there is a 50% chance that I'm going to not get blue or yellow, or there's a 50% chance that I will get green or white. So let's look at some cards, same problems. You might want to try these on your own and then come back. So maybe pause it and then come back and try them. Okay, so what's the probability of drawing a red card, replacing it, and then drawing another red card? All right, we're going to replace it. So drawing a red card, there are 26 red cards out of 52. So there are 26 out of 52. We're going to draw it. Look, we got a red. We put it back. Now I want to draw a red again. Well, how many red cards are there? There are 26 red cards. How many cards are there? 52, because I put them all back. And I multiply them together. Well, 26 over 52, if you want to see it like this, maybe it not look so ugly, 26 out of 52 is half and half. Well, 1/2 times 1/2 is 1/4, or a 25% chance of drawing a red and then a red. Okay, so how does it change it if we don't replace it? Well, we draw a red card. So we've got 26 out of 52. There are red cards. I don't replace it. I reach in, I draw. Oh, look, I got a red card. I put it to the side. Now I want to know the probability of drawing a red card. Well, there are 25 red cards now in the stack, and there are 51 cards now all the way in, completely in the stack. So when I multiply those together, I get 0.245. So it's not much less, but it is a little bit less of a probability to happen when you don't replace the card, which makes sense because now you have fewer red cards to choose from. What's the probability of drawing a red face card, replacing it, and then drawing a black ace? Okay, so let's look at this. So drawing a red face card. So if we go back up here, we have 6 red face cards. So it's 6 out of 52. I reach in, I get one, I look, oh, I got a red queen. I put it back in because it says I replace it. And then I draw a black ace. Well, how many black aces are there? Well, there are 2 black aces, and I put my card back, so there are 52 cards in the deck. So when I do that, I get 6 out of 52, 6 over 52, times 2 over 52, and you get 0.0044. So that is a 0.44% chance of happening. So it is not very likely that you're going to draw a red card and then draw a black ace. It's not very likely to happen. You wouldn't make a very big bet on that kind of thing happening. So last, let's look at two completely separate events. These are independent, obviously, because one isn't going to affect the other. What you spin on the spinner doesn't affect what you roll on the dice. So these are considered an independent event automatically. So what's the probability of the spinner landing on a yellow and then rolling a number greater than 4 on the dice? So what's the probability of it landing on yellow? Well, there is one, these are equally spaced. There is one of the 4 spaces is yellow. And then rolling a number greater than 4. Well, it's 1, 2, 3, 4, 5, and 6. So 5 and 6 are numbers that are greater than 4. So there are 2 of the 6 that make me happy. Well, I can multiply these, and so you get 1 times 2 is 2, 4 times 6 is 24, or 1/12 is my reduced fraction form, which is 0.083 or 8.3%. So again, probability when you have multiple things happening, right? If I want this and that to happen, you would find the probability of each one and multiply them. Think about, okay, what happens if you put them back or don't put them back? Just physically, like how many cards do you have, how many dice, how many marbles, whatever it is. But then if it's an or, then you would add them together.